everyone, welcome back to MTechZudo, where we make tech learning simple, clear and fun. Have you ever wondered how your computer, phone or even your smart TV knows where to send and receive information on the internet? It's all thanks to something called an IP address, the digital identity of every device connected to the internet and network. Today we will break down what an IP address is, how it works and the difference between IPv6 and IPv4 in the simplest way possible. Let's start with the simple basics. Every device connected to a network, whether it's your phone, laptop or even a smart refrigerator, needs a unique way to identify it. An IP address or Internet Protocol address is just like your home address but for your device on the internet. When you send data like opening a website, your device uses its IP address as the return address. So, the server knows where to send the data back. In the simple term, IP address equal to digital address of your device. The structure of IPv4 address. Now, an IP address isn't random. It follows a structured format. The most common type of IPv4, which looks something like this, 192.168.1.1. It's made up of 4 numbers, each between 0 and 255, separated by dots. Each part is called an octet and together they make a 32-bit address. This means IPv4 can create about 4.3 billion unique addresses. Sounds like a lot, right? Well, not really, because with billions of people and devices connected, we have already used up most of them. That's where IPv6 comes in. IPv6 is the newer version of IP addressing designed to solve the shortage problem. An IPv6 address looks like this. Yeah, it looks longer and it is IPv6 uses 180 bits, 128 bits compared to IPv4's 32 bits. That means we now have a mind-blowing number of possible addresses, around 340 undecillion. That's a 340 followed by 36 zeros. With IPv6, every device on earth and even future devices can have its own unique address. How IPv4 and IPv6 works together. Both IPv4 and IPv6 serve the same purpose, identifying devices and guiding data from one point to another. Here's the catch. They are not directly compatible with each other because they use different formats. So, many networks today use something called dual stack technology. It allows system to use both IPv4 and IPv6 simultaneously. Now, public versus private address. Let's make it even simpler. There are two main types of IP addresses we will hear about. Public IP address and private IP address. Public IP address, this is your device's global address on the internet, assigned by your ISP, Internet Service Provider. It's visible to the outside world. Now, private IP address, this is used inside your home or office network. like 192.168.1.2. It's local and only devices within your network can see it. So, when you connect to Wi-Fi at home, your router uses network address translation (NAT) to bridge between your private and public IPs, kind of like a translator for your internet traffic. Now, why IP addressing matters? IP addresses are the backbone of all online communication. Without them, your messages, emails, or videos wouldn't know where to go. They make sure that data from your device reaches the correct destination and that the responses comes back to you, not someone else. Whether it's IPv4 or IPv6, the goal is the same. Identify devices, route data, connect the world. Now, real world analogy. Think of it like sending a letter. Your IP address is your home address. The server's IP address is the destination. Routers like postal hubs forwarding the mail to the right area. IPv4 is like using short street names in the crowded cities. IPv6 is like expanding the map so every house gets its own unique address. And that's the story of IP addressing, the invisible system that keeps your digital world connected. We learned how IPv4 works, why we needed IPv6, and how both help your devices talk to each other every single second. If you found this video helpful, don't forget to like, subscribe and turn on notifications to keep learning with MTechZudo. Thanks for watching and I'll see you in the next episode.